Hi, this video is about C++ classes and dynamic memory as they relate to classes. First, a little review of dynamic memory in the C++ language. Remember that by default, when you declare an object, a variable, it is allocated in static memory. And that's a very convenient way to create variables. It's what we teach students at first. There's a technical problem with that, though. The static memory segment is limited in space, usually to only a few megabytes in most operating systems. And that's not enough for the volume of data that most practical programs need to use. There's a solution for this, which is that large objects need to be allocated in dynamic memory. This is a different segment of memory, and there's no effective limit on how much dynamic memory your program can use. It's really limited only by your host operating system and hardware and what it can provide to your program. However, this flexibility comes with an added responsibility. The programmer must make sure that their code explicitly frees every object allocated in dynamic memory. It does not happen automatically. Here are some examples of static and dynamic memory allocation. On the left, we have int a, that's a statically declared single int, and we have b is a statically declared array of 1,000 ints. Those would be automatically freed by the runtime as soon as a and b go out of scope. The programmer doesn't need to worry about freeing a or b. In the right column, we have examples of using dynamic memory. C is a pointer to a single int allocated with the new keyword, and D is an array of 1,000 ints allocated with the new keyword. So C and D exist on the heap. They're allocated dynamically. That means the programmer has a responsibility to write code that eventually deletes C and also deletes D. And you can see I put the ... ellipsis in between. If you create C and D, you would use them for something productively, but when you're through with them, you would free them with delete, and we can see delete in the bottom right corner. Now let's review some terminology about object-oriented programming, class data members, and constructors and destructors. A class is an object-oriented data type. We build object-oriented software out of individual classes. A class connects functions and data into one thing that operates independently. A class member is just a thing inside a class, and there are two major categories of class members. First, a data member is a class member that is a variable. So this is where you store regular data inside an instance of a class in a data member. A member function is a class member that is a function. So it's a function. You can call it, it can return things, it can have arguments. It's a function, it's a member function of a class. A constructor is a special designated function that is responsible for initializing the data members of a class, and the constructor's name is always the same as the class's name. The destructor is kind of the opposite of the constructor. It is a special member function that is responsible for destroying the data members. So if there's any cleanup that needs to happen when a class is destroyed, the destructor is a function that's responsible for doing that cleanup. And a destructor's name is always the name of the class, but with a tilde character in front. Here's an example showing some of this stuff. This is a class called date. It's just representing a calendar date with a int year, int month, and int day. So we've got a constructor to begin with, and I'm using list initialization to initialize the private data members. I've got int year underscore, month underscore, day underscore. I'm using the convention from the Google style guide, which says that when you name a data member, such as year, month, and day, we need a way to distinguish the data member variable name, what I declared down here, from a argument variable name. And the way we distinguish that is that the member variables have an underscore at the end. Frankly, it's a little bit ugly, but it solves the problem. And if we're consistent about it, you kind of get used to seeing that. So I've got my constructor up here that creates an object and initializes every single data member. I've got my destructor here. Note that the constructor's name is capital D-A-T-E, date, just like the class name. And the destructor is the same identifier, capital D-A-T-E, but with a tilde. And this is an empty function, open curly brace, close curly brace. In this case, the destructor does not need to do anything because int, year, month, day are all declared statically. so there's no need to delete them or do any other kind of cleanup. Here I've got my int year. This is an accessor or a getter. It just returns the value of year. And there's a ... ellipsis. We would probably have more stuff in a practical date class. There's a concept called a default constructor. The default constructor is a constructor that takes no arguments. So a constructor is a function. It can take any number of arguments, including 0. The default constructor is a constructor that takes 0 arguments. For instance, with our date class, we could have a constructor date, open paren, close paren. This would be a constructor that takes no arguments. So it would need to initialize a date with no given year, month, day. It would need to pick something sane for those 3 values. There is a implicit default constructor. That's used unless you write your own. So if you do not create your own default constructor, the compiler will implicitly create one for you. What that default constructor does is it calls the default constructor on each of the data members. So this works fine if every single data member you have would be initialized properly by its own default constructor. For example, if I had a class name, this is a person's name, and the data members are a first name and a last name with the underscore naming convention. String is a class. I'm using the standard string class in C++, and string has a default constructor that initializes a string to be a valid empty string containing nothing. So the default constructor on first would create a valid initialized empty string. The same thing happens for last. So in this case, the default constructor for name would just create an empty first name and an empty last name. And while that's a little bit nonsensical for most business logic use cases, that would at least be a properly initialized data object. So I think that would be okay in this case. The implicit default constructor would work fine for that case. There's a similar default destructor that's used unless you write your own destructor. And the default destructor calls the destructor for each data member in turn. So that's okay if none of the data members need to be deleted. But it's not okay if the constructor allocated dynamic memory with new, because if the constructor allocated dynamic memory with new, the destructor is our last chance to delete that, and we are responsible for deleting that memory. So here's an example of code with a bug. This has a memory leak because my constructor allocates dynamic memory with new, and that memory is never freed with delete. I have my dynamic date. It's a iteration on that date class, but now for some reason I'm storing the year, month, and day in dynamic memory. So date is passed a int year, int month, and int day, and I initialize pointers to ints by allocating new int year, new int month, new int day. And this syntax here calls the copy constructor on the int type, which will allocate a new int on the heap dynamically and copy the value of year with no underscore into that new int object. So there's a bug here, there's a memory leak. When a dynamic date is destroyed, there's nothing responsible for deleting year underscore, month underscore, or day underscore. That can be remedied by writing my own explicit destructor that simply does that. So tilde dynamic date deletes year underscore, deletes month underscore, and deletes day underscore. It's not difficult. It's really an attention to detail thing. We just have to remember that if the constructor allocates with new, the destructor has to free all of those things with delete.